The topic of maxima and minima of quadratic functions is very well suited for word problems. Let me show you one such text problem. Let x and z be two numbers that add to 12. So I'm having two numbers that add to 12. The numbers are called x and z. Let's choose x and z so that their product, x times z, is the maximum possible. Okay, so we read our problem. Now let's try to formulate the various statements of the problem into formulas. So let's do that. First of all, what are we trying to do? We're trying to maximize the quantity x times z. So we're trying to make this as large as possible, x times z. What are we given? We are given that x, the sum of the x and z is 12. So we're given that x plus z equals 12. Well, now we don't know how to maximize a function of two variables, but this is not really a function of two variables because see, if x plus z is 12, I can actually solve for z. I could transfer x to the right hand side and then I'm getting that z is 12 minus x. In this way, I have eliminated z. I have boiled down the expression to an expression which depends solely on x, right? Because z must be replaced with 12 minus x. So I'm trying to maximize x times z, but since z is 12 minus x, I'm actually trying to maximize x times 12 minus x. So let's uncover the parentheses. X times negative x is negative x squared, and 12 times x is, well, 12x. So I'm trying to maximize the function negative x squared plus 12x. But that is a parabola. So a parabola which opens down, right? Because its leading coefficient is negative 1. So negative x squared, that's in fact negative 1 times x squared. So the leading coefficient a is negative 1, so the parabola opens down. So since it is a parabola which opens down, it has a maximal point, and that's going to be for the values of x and z for which that maximal point is attained. That's going to be the answer to our problem. I want to just point out that if the parabola, so when we uncovered all the parentheses, if the parabola was opening upwards, then our parabola wouldn't be having a maximal point, in which case the problem would be incorrectly posed, because we wouldn't be able to choose x and z so that we get a maximal value for x times z. But because the problem was formulated the way it is, we got a parabola with a negative leading coefficient, hence we know that it has a highest point. Okay, so our parabola has a maximum, and where is it attained? Well, it is attained, actually, let me ask you, where is the maximum of that parabola attained? I'm sure you guessed it correctly. The maximum of the parabola is obtained at minus b over 2a. Right, so, well, what's b and a? Well, b equals 12. That's the coefficient of x, and a is equal to negative 1. A is equal to negative 1. So 2 times a is actually equal to negative 2. So 12 divided by 2 is 6, and minus times minus is plus. So this cancels down to 6, and my final answer is x equals 6. What about z? Well, z is 12 minus x. X we just saw was equal to 6, so z is 6. That's it. The problem asks us for the values of x and z, and we got them, 6 and 6. Actually, let's read the precise formulation of the problem choose x and z so that the product is maximal. It is not completely clear what's our final answer. Do we just need to give the value of x? Do we just need to give the value of z? Or the value of z, the value of x, and the value of the product? When that's not completely clear from context, just indicate everything. So in this case, we indicated what x is 6. We indicated what z is, that's equal to 6. And let's indicate the maximal product. The maximal product is x times z, which is 6 times 6, which is 36. So our maximum is attained when x is 6, z is 6, and their product is 36.